That's my buddy Stefano Creatini. He's a fellow YouTuber and he posts a lot of content about permaculture and farm tours and things like that. He lives across the river from me and he called me up one day and he said, "Hey, would you like to do a collaboration on a rocket mass heater?" And I said, "You bet," because I've always wanted to build one and I never had until we shot this one. And this is a Walker Stoves, Matt Walker's design. He's also a YouTuber. You can find his content here as well. And the unusual thing about this design for a rocket mass heater is that it does not use the ubiquitous inverted barrel in the design of the stove. So it's a brick-based stove instead of a cob-based stove with some interesting features. And after putting this into Stefano's house, he was able to reduce his heating bill to almost nothing, just burning wood in this stove. So let's get into the build.
How we looking, Bob?
Looking pretty good.
Just crawling in the crawl hole.
This masonry stove is going to end up weighing about 1,500 pounds. So down here in the crawl space, we're adding some supports. Because there's a radon barrier in this crawl space, we couldn't really pour footings, so I just used those 12-inch pavers underneath the legs of this brace that we're going to put up here. This is coming off of the center beam of the joist system, about 6 feet or so. This build of a rocket mass heater is in a conventionally framed home, so I'll give you an idea of what can be done without having a pad underneath the installation. We're pulling out this old pellet stove. The electronics on it stopped working, and getting all the tack stripped up to clear a place to start doing some masonry. Got a truck full of sand and this fire clay. This stuff runs about $50 a bag for a 50-pound bag. We ran short, ended up needing 3 of these to complete this project. And the mix here is just 3 parts sand and 1 part fire clay with enough water to get to a consistency that will hold the tools but also be thick enough to support the weight of the bricks. About this mortar is because it's just clay and sand. There's not a chemical reaction that causes it to cure. It's just drying. So we can mix this 4-gallon batch and just cover it when we're done for the day, and it will remain viable until it dries out. So as long as it's either covered with a layer of water or a lid, it'll remain good for as long as we need. We ended up burning up this mixer in this process. This was better done in a wheelbarrow, but this thing was on its way out anyway. So we just keep adding water until we get to the consistency we like, which looks about like that. It'll hold to the trowel, but it's thick enough that you can set a brick on it and it won't just squish out. Stefano reached out to Matt Walker and asked him if he would be interested in giving us a discount affiliate link or something like that that we could pass on to you guys. And he wasn't interested, but I can give you an honest assessment of this PDF package of these plans. By and large, the design is very good. There are a lot of great things about it. The plans, like some of the measurements, are in decimal points instead of fractions, so you know, if you can get around that minor detail and just stay true to the dimensions of that first layer when you lay it, you should be all right. He says that it's a beginner level masonry project. I'd say it's a little more intermediate. There are some things that you should know to be able to complete this stove. in good fashion, but it's pretty accessible for somebody who doesn't have a whole lot of experience with masonry. There are no indications of amounts for things like the fire clay in the plans, and as I mentioned, this one required 3 bags of 50 pounds each of fire clay, and fire clay is a specific type of clay, usually tends to be rather high in aluminum and silicates and things like that, and can be found at a lot of fireplace stores, ordered online. It's not common, but it's findable. So the plans are pretty good, with those few exceptions, and I think if you're at all handy, you'll be able to figure it out from what's provided. So here are the plans. This is a PDF available from Walker Stoves. I think it runs about $150, something like that. The plan has a diagram for every level of bricks. So we start with the pattern on the floor. And then we make an insulative barrier of perlite and fire clay that will fill that first layer of bricks and provide 2 inches of refractory insulation that will be between anything hot and the wooden subfloor down below. So we just added enough water to make a popcorn texture with this and fill all the voids and get it leveled out. So there is a nice thick insulative high temperature barrier. And the process from there is just going through every page of the plans and setting the bricks according to the pattern, leveling, squaring, trying to keep things as nice as possible. And we're at the point where we're at the top of the bench, so we're going to use this bed rail to cut up some angle iron braces to carry the tower on this side. And we set those in a little mortar and get them squared up. So we're rapidly getting to the place in this build where we're going to need to build the core. And for that we'll need a door assembly so that we can make all of the cuts and the rest of the material that are appropriate to the door we actually have. So we had to turn to one of our local neighbors and have him help us out. And that would be Ira Houseward. So this is his homestead, his shop dog Cora, up there on Rogers Mesa. They're about 5th generation homestead family from this area. And his shop is like a pirate ship on fire. These guys have 27 projects going all the time. They build beautiful handrails. They're working on these benches for the various branches of the service, for our cemetery locally. And that's our plan for our door. We wanted to have the mounting plate and the door in 2 parts. A little tricky because the door has some insulation built into it, so we need a 1-inch ridge around the outside. And there's Ira doing what he does. Not only is Ira a great neighbor and a member of the community and all-around super nice guy, but he also is very talented at what he does and is a 2-time winner on Forged in Fire, most recently beating one of the judges in an all-star competition. This is his apprentice doing these welds, and so he's got about 6-8 guys employed up there at the shop. But they made short work fabricating this chunk of metal for us, having the plasma cutters and everything running all the time. Sure makes things quick. So we added this 2-inch flange on the mounting plate for the door, and it will protect the edges of some ceramic fiber board so that when you're feeding logs into the stove, you're not dinging all that stuff up. And there's our door and faceplate. Just going to need some hinges. And if your hinge won't open, it sure is handy to have a forge.
Yeah, so I use muriatic for rust.
You bet. That'll hand.
I think the hinges may be older than all of this right here.
Yeah. About as old as that plow.
So yeah, from the homestead.
Yeah.
Probably found it out in the dirt somewhere.
Uh-huh.
With the hinges sorted, now we need to figure out some sort of an operable clasp to close and open this door. So I already just started with the forge and the hammer and anvil, and did a little art for us. After some trial and error, we managed to settle on this configuration. And this will allow the door to operate within the brick work that actually protrudes past this door on this build. There we go. They knocked this out in about an hour and a half. And that is a pretty good solution. And there it is, where it's going to go. Now, we built this just before the premiere of the episode of Forged in Fire. Now, the ceramic fiber board is an interesting material. It's typically used in boiler applications and forges and things like that. It's a little spendy. So each of these sheets that I'm about to show you costs $100. And we tried to get a layout on one size of sheet that would be the most efficient. And we'll show you exactly how we laid it out here if you want to build this yourself. And you can be as efficient as possible with this material. Although it is expensive, it makes this build quick, and it solves a lot of the complex problems of like pouring castable refractory material and things like that. So it's a good solution in terms of efficiency and ease of working with it. As I mentioned here, the dust from this material is not something you want to breathe. So be sure to wear adequate dust protection when you're working with this material, when you're cutting it, even with the wet saw. But you know, it's It doesn't hold up well to abrasion, like logs jammed into it and that sort of thing, but it is easy to work with. It makes this build fairly quick, but it is expensive. So there are other ways to approach this problem, but because it's a hyper-insulative material, you get a very hot burn in the stove, and that's what you want in a system like this. That's back and one of the sides, okay. Inner front, floor, port, and top. Front, back, base, 2 tunnel sides. The other side, inner back, and the tunnel floor. This material cuts super easy on the wet saw, but do not be confused into thinking that there isn't dust. As you can see, blowing in the wind, this stuff is super harmful to breeze. So absolutely dust protection. So here we are. This is the magic of this design, is the use of the ceramic fireboard to make this not only burn chamber, but also the base of the heat riser. And so we're test fitting all the pieces. This is one of the pieces that will be cut to accommodate that flange on the door mounting plate, and this one as well. Now we did decide to replace the ceramic fiberboard on the interior of the burn chamber with fire brick, because we noticed that in Matt's videos he talks about a good deal of wear from just logs hitting that when you're feeding the stove. So we wanted something a little more durable and had to make a few modifications for that, but essentially ended up with the exact same dimensions and pattern on this finished core.
You got a knife on you, by any chance?
I have 2 knives on me.
So that's the basic idea
Just like that.
of how this core works. Burn chamber in front, bottom of the heat riser in the back. Now to mount our door assembly, I needed to put some masonry anchors in the brickwork for angle iron. And once we had that in, we could start actually building this core. So for an adhesive on this ceramic fiberboard, I'm just using a slurry of fire clay and water. Kind of a putty consistency, and this is basically just going to stick these together. Once the stove is fired, they should be pretty well bonded. But the architecture and the geometry of them is self-supporting, so even if we don't get a perfect seal with that, at least it's like a gasket to make sure we contain all of our flue gases within this burn chamber. The way this thing is designed, it runs at a very high temperature, upwards of 1,000 degrees. And so these little pieces we're sticking in just to make up for the thickness on the fire brick we're using on the sides. It's actually 1 1/4 instead of 1 inch like this material. So these are just filling in the floor area, and then we'll just set brick on top of them. Those in, we can put the actual floor. And that notch down the middle of that is for the secondary air. This layer will be capped, which is just a 1x2 steel tube square with a standpipe in the back. So these are scraps that I've cut to fill in where the sidewall pieces we omitted to accommodate for the bricks would have been. And there's our port. So this has a vertical slit that just allows flue gases to swirl into the heat riser. and they combine at that point with fresh oxygen from the secondary air intake, causing combustion of all of the various producer gases that come off this fire. So we're going to be burning all of the hydrogen, carbon monoxide, methane, everything that normally makes up smoke in a conventional wood stove is getting burnt in the heat of this heat riser and in the presence of that supplemental oxygen. And that is part of what makes this sort of a stove so efficient. It's going to heat this home on a tenth the wood that it would take in a conventional wood stove. Part of that is the burning of all of those secondary gases, but the other part is the fact that this 1,500 pounds of clay is going to hold and radiate that heat like a battery throughout the course of the day. So here are the fire bricks, cut and ready. And there is our secondary air assembly. Now, you may be thinking, well, this mild steel pipe is not going to last very long. And
Perfect size, Rafi.
you would actually be correct. At one point in the first month of operation, it got filled with some ash too. So without air flowing through it, it absolutely crumbled within a month. So black pipe can be used here, or you can get a specialty alloy from rolledalloys.com that will sustain at higher temperatures for a permanent installation here.
But it's tough.
I just provided Steph with a bunch of extra parts for this, so we can switch them out until we can get something better in there. And there it is, with the lid going on. And the brickwork just goes right across the core, and we continue up with this tower.
You want me to cut some mid-sized bricks
We're all fulls.
for the rest of this?
Yeah.
And there's the tower going up. Those pieces sitting on the bench there are actually the sides of the heat riser. And we're going to assemble that in much the same way we built the core, using the same slurry, fire, clay, and water. But we're also going to get these lined up and use these 18 gauge brad nails as pins to hold them together. Now once again, once this fires, that clay should bond the different parts together. But we'll go ahead and pin it just to make sure it stays stable. Eventually those nails will burn out, as will this stainless steel wire that I'm going to wrap this with. So it'll last for a while, but it's mostly just to hold it until it's been fired to the point where all of that fire clay is fired off, and this thing will be basically a single unit. This ceramic fireboard is rated to something like 1200 Celsius, so far hotter than we're ever going to get. So the bottom of the heat riser gets the slurry of clay, and down it goes. And this just sits on top of the core assembly in the back. There's very little clearance on any side of this thing except for on the right side. There's a fire chamber, the secondary air, and the heat riser coming up. And then that's where the flue will go. And so the fire burns up, down past the flue, and into the bench. So we needed bench tops, and a top for the tower and a top for the burn chamber. So we decided to pour some castable concrete countertop material for that. You can see I've put a end cap for a 6-inch stovepipe in that first form, and that's to leave a void for the pipe to exit the stove. So we bought Quickcrete's countertop cement mix, a little expensive, but it worked pretty well here. Just using a bladeless Sawzall to vibrate any air bubbles out of this, because you definitely don't want these to explode once the stove is fired. And that also gives us a pretty good smooth finish. About 3 days later, taking the forms out, we applied caulk to all the corners, of course, to give ourselves a nice bullnose finish on these. And also seal up the forms so nothing leaked out. Getting this cap out of here was a bit of a struggle, but eventually I was able to knock it out. And of course, that diameter is the inside of a stovepipe, and I need to grind this to the outside diameter of a stovepipe using a flap wheel on the angle grinder. And eventually we got it to the right size, very tight fit, and tuned up the edges of our concrete countertops just to get that nice smooth bull nose. And at the top of this tower, this design calls for a sheet of ceramic fiberboard at the top, and in his plans he says just set it on top and then set your countertop on top of that. But I didn't really want to have that full inch grout line at the top of the brickwork, so I recessed the fiberboard into the bricks by taking a little notch cut out, and we built this up just from scrap, which worked out pretty well. Looks like the apprentice got after this hole with an angry beaver, but it'll do. We'll just pack that in with mud. So there we are, ready to set that first countertop on. And had a few issues. Got the brick a little bit out of alignment in the process, but figured we'd just leave it rather than mess the whole thing up by trying to pull it and do it a third time. So here I am cutting a recess in some of this ceramic fiberboard that will go into the door, and this recess will cradle the fireglass that we found on eBay, the 6x9 piece of fireglass going into the store. And so I'm just using the oscillating tool to hollow out this void where that glass can sit and be secure inside of the door. And then I'm using a high temperature caulk for this, and essentially using it like an adhesive, so running a bead around where the glass will go and then around the corners of the metal that will hold the insulation in place. So there's the fireglass, and in we go. Just press that into that bead of caulk. Now we need to leave the bottom section of this door open, because that primary air port there is what feeds the oxygen to the initial fire and also acts as a wash to keep buildup of soot from developing on the glass. So there it is, door in, caps on. Got a flue installed, took out the old B-vent and put in a conventional run of 6-inch stovepipe with insulated above the ceiling here. And lighting our first fire.
It's drawn. Look at that.
I know, but then, you know, at least her other needs.
It's working.
And there's no smoke billowing out of the stove.
That's usually a good sign.
We'll call it a win.
So, using my, let's see how hot we are in the back of what we can see. So, see there, over 966 Fahrenheit. If we hit the center of the burn chamber, it just goes the highest. So we're over 1,000 Fahrenheit, which is crazy hot. That's burning every gas that this fire is emitting. So you actually don't smell this wood fire outside at all from the exhaust. So super hot. Let's test this. So it's about right over there, 200, 12. Go up to 42. So the way it goes up that way and then comes down, that's how the fire, so it should be cooling down, and it does. As you see, it comes down. We work away. So 166, let's see, top of the bench where you put your warm bum on. $160, $130, $5.
So now that the stove is complete and has been operational for a little over a month in Stefano's home, there are some things that we've figured out about it. We're wishing that we had placed it a little further away from the wall. The wall behind the tower on this stove can get up to 200 degrees, and that's a little more than we'd like. We've added a reflective shield behind that portion of the stove. Not that it's absolutely necessary, but just for a little peace of mind. It also has insufficient mass to really be in that once a day or twice a day burn zone. He tends to burn a few times a day to keep the house comfortable, but it absolutely does do that. It keeps his 1,600 square foot ranch style house evenly warm with ease and not with very much wood. So if there was a larger bench, then absolutely it would be more efficient because it would bank more heat. The other thing that I would probably change about this configuration, he has that flue pipe running next to the heat riser, and that keeps everything compact, and that's nice. But I have some concerns that the intense heat coming off of that heat riser will degrade that stovepipe that's inside of the masonry rather quickly. He gives the option of putting that stovepipe at the other end of the bench, which I think I would do if I was building a stove again, and I would build a much larger bench. Another thing that should be explained is in a conventional rocket mass heater, you usually have a flue run through a cob bench that goes out and turns and comes back, and you have your standpipe going out next to the barrel. In this one, he's using a bell method for that mass bench, where it's just a hollow void in there, and the placement of that stovepipe within that tower is such that it's about 8 inches off of the floor of the unit. So what happens is the hot air goes into the bench, and then it stratifies. The hottest gas is rising to the top, and as they cool, they get down to where that opening is for that stovepipe going out. So it's about 8 inches from the bottom, or a brick stood on end. So there were 3 bricks in there that we slid the pipe down, and it's resting on those. So yeah, you basically extract heat from the gases, and as they cool, then they evacuate up the chimney like that. Well, thanks for watching, and be sure to check out Stefano's channel and also Ira's channel over here, and you can see a lot more of his work. He has a good Instagram feed as well, and I believe he's also on TikTok, so lots of good stuff coming out of Ira's shop, and we look forward to seeing you again on the next build.